think? David, do you want to go first, or will we be kind enough to let Steph take over?
I think we'll do it this way. Yes.
Okay.
Yeah, Steph should start.
Steph, how are you doing, Steph?
I'm good. I don't know if that's kind.
Yeah. We're being nice to you. It's like ripping a Band-Aid. You get it done first, and then everything is fine.
I hate being on the center of attention. It's really nice to see everyone, though. It's nice to see some friendly faces. Hi, Alan.
Oh yeah, Alan's here. Hey, Alan. I've got Lillian and Megan here too from your paper. Oh yeah, I've just unmuted them. Hi, Lillian. Hi, Megan. How you doing?
Good, thank you. How are you?
Good. Nice to see you both.
Hi.
Thank you so much for having me.
Yeah. I'm going to premise this whole intro to the paper with the fact that I'm not a gull expert. I am more of the pelagic seabird type of person, but I do like gulls, and I found this paper really interesting. So what Lillian and friends did was look at plastic ingestion or the boluses of gulls in Tasmania, collecting a huge number, 374, which is quite a feat over a year and a half, I believe, and then dissected them. And I have many questions about the contents. I have many questions about rocks and glass, but we'll get to that in a minute. And then, so they analysed it using very good standardised methodology. Pleased to see there, and then I don't know. I mean, it's such a good, like, not simple, but it's a really good, clear paper about what these birds are eating. And I don't know that I know in New Zealand that the gull population had declined somewhat, and Alan, maybe you can correct me or back me up on this, when landfills started becoming more managed and covered, and then covered with dirt and things like that to reduce scavenging by gulls and things like that. And so there had been a population expansion, but then a decline as well associated with the different management of landfills in Aotearoa. And so it's a really interesting kind of perspective to think about how the gulls are actually getting affected by human activities. So very much interrelated. We like to think sometimes as ecologists of these species that are separate from urban ecology, and gulls are such a great example of a species that thrives in human environments, and how they're being affected by them. And so this paper was really interesting from that perspective for me. I don't want to talk too much more, so I'm going to pass it over. I'm going to ask one question and then pass it over to Lillian, because I really want to know, why are they eating rocks, so many rocks?
I believe that rocks are a natural element to their diet, and I believe they're simply eating them to assist with the mechanical digestion. That's
so is that much like more like with the gizzard stones?
Yes, I believe so. Yeah, that's pretty much what I found. It's quite a simple answer. Sorry, but yeah, I believe it's just to assist with the mechanical digestion. So that was considered a natural prey item that we recorded.
And then they obviously eject them. So then the other question I had was about the plastic and the rocks in summer, and so why there was a seasonal difference between or less plastic that was found in the boluses in summer versus rocks, and what do you think is happening there?
So basically the slight difference that we recorded in the summer, we believe, but we don't have strong evidence to suggest this, is that some of the birds, because we have juveniles through to adults in our site that we were studying, we believe that either the juveniles or the adults perhaps were going elsewhere, because the summer in Tasmania is their breeding season. So that's through the October, December sort of range. We believe that some of the birds have been moving away, possibly to breed, but I can't say that with 100% confidence. And so we just believe that different aged birds are foraging slightly different. This is something that needs to be looked at in depth in future. But we just believe that that population is changing. They're moving away, and that's sort of playing around. And so we believe that, say the juveniles are eating slightly differently to the adults. Maybe the adults eat more plastic, then they disappear, and that just sort of changes the results that we were finding. But that's definitely an area that we really would welcome some future research in. I hope that answers your question.
Yeah, absolutely. I don't know. So is it like an open forum and people can just jump in with questions whenever they want, Grant? Is that the format? Okay, cool. I have more.
I mean,
people can stop if they don't
flexible.
have anything. I have more.
We're very flexible here at Seabird Sessions. I wouldn't worry too much.
Okay, I wanted to bring this up earlier and I didn't, but I have a more of a it's not strictly related to your paper as such, which I want to get back to momentarily, but I have to bias my I have to present my bias that I've got a bit of an academic crush on Jennifer Lavers, and if I had even a small proportion or a fraction of thought that I might survive another PhD ever in a million years, I would love to do it in the Adrift lab with Jen and with Alex. And I just wanted to get your perspective on, I've heard that she and Alex are really good supervisors, the kind of supervisors that make your grad experience, and I just wanted to kind of get your perspective on that and share it with the whole group. Hopefully I'm not wrong. I don't think I am.
I don't think you've heard this from me yet, Jen. I know she's tuning in there, but I think we all shared that academic crush on Jen. Don't blush too much. No, Jen's fantastic. She's a wealth of knowledge. Alex as well. Alex is fantastic, especially in things like stats and numbers, where a lot of us very young, early career researchers often shudder at the thought of doing new things that that are just not as attractive as doing the fun field work sort of thing. But they're so fantastic. They're incredibly supportive, and they've definitely seen the best bits and the tears, and they've been fantastic throughout. So I can 100% vouch for Jen and Alex. They're just fantastic.
Yeah, good. No, go ahead, Megan.
Oh, I mean, I was pretty much just going to second everything Lil said anyway, but I mean, for me, so I was one of Jen's honours students back in 2017, and one of the sort of like not the sole reasons, but one of the main reasons why I continued on to do my PhD was because Jen and Alex both wanted me as a student, and I was like, oh, yes, I don't want to do my PhD with anyone else. Not that I've met all that many other people, but I mean, Jen and Alex, yeah, both fabulous people. Love them to bits.
Yeah, more people like that in science, eh?
Absolutely.
Yeah, I've always wanted, I mean, like, just such powerhouses in the plastics research field, and in terms of my knowledge of what's impacting our seabirds, especially in the South Pacific and Australasian waters. There's not a huge amount of research going on here, and Jen and Alex really have led the charge in that. And so yeah, I mean, I really don't want to do another PhD, but I kind of do. But I don't.
Doctor.
Oh, and yeah, Adrift Lab is actually recruiting PhD. So if you know anyone who wants to go there, I would love to. So going back to your paper, Lillian and Megan and Jen and Grant and Alex, who some are, and Peter, sorry. No, there's no Grant.
No, there's no.
That's my last name.
That's Megan's last name.
I've had a really long day with lots of Zooms. Just gonna put that out there. One of the results that I was kind of interested in is the sheets of plastic, and that, do you think that they're prevalent because they're feeding in the landfill and they're sort of picking through packaged products and tearing apart those packaged products to get at organic matter, and then ingesting those plastics at the same time? And And yeah, and what was your perspective on the high rates of sheet plastics?
Yeah, so I think so. I mainly study shearwaters, flesh-footed shearwaters with Jen, and I guess that the plastics that we see in those are more often than not hard plastic fragments. And we never find sheet plastics. Very, very rarely find thread-like plastics, and very rarely find polystyrene. And then you compare the shearwaters diet to, or the shearwaters, the plastics that shearwaters eat to what we're finding in the gulls, and it's like black and white. We don't see those hard plastic fragments, especially not those with the weathered soft edges like we see in our truly like pelagic birds, I suppose. And yeah, we found huge amounts of sheet plastics, which we think they're either eating them, like you said, to get to the organic material within, or because they just have or smell like food as well. So we found, say, a lot of butter wrappers that the birds have eaten, and just general sort of wrappers and things from food items. So because of the high amount of sheet plastics, as well as like polystyrene, so we found lots of little like polystyrene balls that you would fill, say, like a bean bag with, and yeah, a whole range of really interesting sort of household items. And so because of those ones that we were finding, we strongly believe that they're feeding at a landfill. But
do you think that's having a like what are the different physiological impacts that might be having on the birds?
I suppose from just like looking at the plastics, so the ones that we find in the Pacific gull boluses, often they have really sharp edges, so compared to the plastics that we find in the shearwaters. So I mean, we found dental floss picks that have like, you know, there's like ones about that long with the sharp bit on the end. We found nails, lots and lots of glass shards, and all of these items have really sharp edges. So, I mean, if you think about it, they have to ingest it once and then it comes straight back out. It comes back out again. So with all of those sharp edges, I can't imagine what it's doing to their insides in terms of like perforations or lacerations and that kind of thing. Apart from that, I guess the residence time of those plastics within their systems is quite a lot narrower than what we'd see, say, in like the shearwaters, because we believe that the Pacific gulls are regurgitating a bolus like once a day, so those plastics aren't sort of staying within their systems for, you know, weeks or months or whatever. So whether the Pacific gulls are getting sort of persistent organic pollutants leaching out into the system or anything like that, we're not really sure. But yeah,
that's
that was going to be my. Oh, sorry, go ahead, Lillian. No, you go.
I was just going to say that was a great answer. I mean, there was so many times when there was like a Stanley knife or X-Acto knife blade that I found, and I was you know, still able to cut stuff with it. So it was as if it's been thrown out and then directly eaten, and it was exactly the same as when it had been used. So absolutely, I would say it is likely that there is some lacerations and internal damage from that sort of thing. A lot of the time we found like beer bottle caps, nails and metal which had rusted, so no doubt that is an opportunity for infection perhaps, as well as if it's still quite sharp. Another thing that we found, which makes us believe that they're feeding from a landfill, is there was an awful lot of bathroom or personal hygiene items. Now, we all know what they are used for, and as I'm sure everyone is aware, there would be bacteria and all kinds of stuff on them. I'm not sure how much would still be present by the time it's been in a landfill and then ingested by the gull, but I would say infection is also an area worth looking into. The strangest item that we found as well on the personal hygiene side was a condom. So I'm positive that that's not doing anything great for the bird. Thankfully, it was able to expel it in a bolus.
Seabirds are absurd. I mean, like, they're
Like
just absurd, right?
that's gonna go down in the quote book.
Sorry, I was doing some gull research before this, obviously, because I don't really research gulls very often, and I did see this, and maybe you're aware of this more than I am, but they've been observed like peaking, and because they're kleptoparasites, they practice kleptoparasitism. It's a really hard word to say. I don't know if you've ever tried to say it out loud, but it's of preying on live whales. They like land on whales as they're breaching and like picking flesh off the backs of whales. I don't know how many people actually knew that was a thing of gulls. Oh, okay. So everybody knew that.
I had no idea. No.
I had no idea. I was horrified. I'm like, gulls have got so much more respect from me now.
Yeah, no, gulls are
absurd.
Often they're hated. They're dismissed a lot. I mean, people they'll drop a hot chip and a swarm of gulls will appear, and they're just, they're not the most loved bird out there, which is quite sad because they're actually really intelligent. I mean, they've also been observed to get shellfish and fly up high and drop it on a rock to then crack it open to get to the flesh inside. So these birds, they're not stupid, and the fact that they're eating from a landfill, I mean, they're generalist scavengers, so they're going to try and get an easy meal using as little energy as possible, and so this is how they're doing it. And I mean, we're throwing out all kinds of things into landfill, oils, fats, interesting smells, which is, I'm going to assume, a lot of the sheet plastic, which, say if you have Glad wrap or cling film, if you've wrapped some food in it and thrown that out, that's going to have residue that smells enticing, and so they're probably going to take that as an opportunity to get a tasty feed. So I mean, yeah, gulls deserve a lot more love, that's for sure.
I think we should start a Twitter campaign of hashtag glad rap is not glad, because it doesn't make anybody, especially the gulls, happy, right?
Hashtag it's sad rap. Hashtag sad rap.
It's sad rap.
That's good.
Sad rap.
Maybe we should, David, do you have any questions for the ladies while you're here?
Great study, and maybe a compliment. Now in many places in the world, people realize what great indicators seagulls can be in coastal habitats where they interact with humans. So there's quite a lot going on about that, and as you said, they're great at detecting garbage and including illegal waste dumps. There's some work in southern Spain by Joan Navarro from Barcelona University, and he showed that when you track the gulls, they lead you to illegal waste dumps. And at the scale of Europe, it's really an interesting topic, because you may know that illegal waste traffic in Europe is more profitable than drugs. So it's a huge thing, and so in southern Spain, the girls Joan tracked, they led him straight to some dumps which should have been closed for 20 years. So there's more and more work about this also from the University of Amsterdam. So you can use these girls as indicators, not only for the waste, but also for pathogens. And another work Joan Navarro did, showing that you can map how you expose yourself to pathogens carried by seagulls. So no, I think they're great organisms and great indicators, but also I'm amazed by what they can eat.
That's fascinating. I had no idea that was even a thing. Illegal dumping. And the gulls are intelligent. That's fantastic.
I'm like, wait, waste trade is more lucrative than
it's a big
Europe.
Yes,
I'm in the wrong field.
My mind is just blown.
Yeah, you've got especially in places like all of southern Europe, waste trafficking is a big thing. You get a lot of money saying that you'll take care of the waste, and then you'll just dump it somewhere and make a lot of profit.
I had a quick question for you about you make some comment about how it could be these gulls could be acting as another vector for plastics from into the ocean, and presumably you're talking about when they're at sea and they're puking up boluses in now when they do that, do you know what kind of frequency that is? So how much plastic are they actually bringing into the ocean? Is it relatively minimal compared to other sources?
So that's a great question, and that was one of the findings that we had. So I'll just explain a bit about our study site. So in northern Tasmania, which just in case you not know, it's a little island state south of Australia, and there's a wetland that's about I think about 70 kilometers inland. Don't quote me on that one, but there's a wetland which is so beautiful. There's so much bird life, and it's a really great tourist destination as well for those visiting the area. And along that wetland, there's a boardwalk which allows you to go really into it and really just get amongst it. And part of that boardwalk, there's a few parts where it goes across like parts of the river. And what happens is these gulls are roosting on the handholds of this boardwalk, and we basically can just walk along and very easily collect the boluses. We believe that they will produce roughly one per day. That will depend on the types of meals that they've had, how much indigestible matter has been acquired from each of those meals. So there will be some variation, and unfortunately we don't have camera tracking data, which would have been unreal, because I mean, just to see a gull produce a bolus would have been, in my opinion, quite interesting. So we weren't able to have that, unfortunately, but we can guess it's around about a day, just from other literature as well. And so what happens, these boluses are sitting on this boardwalk, and it is also incredibly windy, and Tassie also gets quite a lot of rain, and there's a lot of weathering factors going on there. And so when these boluses are sitting there, there's nothing stopping them from blowing or from getting knocked or breaking down into the wetlands and river that sits directly below this boardwalk. So I believe it was around, our average had about 8 pieces of plastic per bolus. So that, you know, if you average that out and take a survey of how many boluses are deposited, it's not like loads and loads, but it is consistent, and it is a lot of individual pieces, quite small pieces, and that gets broken down even further. So I'm sure that there are some gulls that go straight to the ocean and the coastal areas to do that, but for our population specifically, it was in a wetland, so that not only lets this debris become available to those wetland species, but obviously all rivers lead to the ocean, so it's just essentially flushing it out. And what we've been able to find is there's quite a lot described in the literature from gulls, like true pelagic seabirds foraging at sea and then bringing that to land or an island for their chick, for example. But that process hasn't really been described as in depth in reverse. And so that was a really interesting observation that we made.
Very cool. Do we have any questions from the audience? I noticed the audience has been unusually quiet today. I see lots of smiling faces, but no hands. But that's okay. All right. So the the colony itself, do you know if is it one source dump that they're going to, or are they traveling to various landfills?
Yeah. So there, within the Tamar River area, there are a number of dumps all up and down the river. So they could potentially be going to any one of these dumps. And unfortunately, we don't have tracking data, but it's definitely something sort of on our radar should we get the funding for it. But so I'm on the campus right now at uni, and the wetlands are over sort of that way, and the rubbish dump, the main one in Launceston, is sort of that way. And every day, without fail, I see huge flocks of gulls going that way of a morning to go to the dump, flying back that way, back to the wetlands of an afternoon around 4 or 5 o'clock. Every single day it happens. So we believe they're mainly eating out of the biggest dump in Launceston, but as there's so many of them, the dumps, I mean, they could be going to any of these. But I mean, it's not just, you know, the dumps or the landfills that they're feeding at. They could be feeding at, you know, other rubbish sources all around the town, some people's discarded waste, sort of anywhere really. I mean, they are true generalists, so and they're scavengers, so yeah, they'll go for anything.
Yeah, they're super fascinating. I mean, I've seen gulls. I remember the first time I saw a gull kill a puffin years ago when I was a wee boy. I remember it shocking me, considering I'd only ever up until that point associated gulls with garbage dumps. I reckon there must be a question on if gulls are further away, you know, if there are more wild populations of gulls, do those gulls breed more or feed more on anthropogenic food sources than the ones that are further out? I guess you guys probably never got a chance to really dig into that sort of question as to whether or not there were more distant colonies that fed on more marine sources of food.
Yeah, and unfortunately not, just not within the scope of this study, unfortunately. But it's definitely something that would be really interesting to look at if we, say, compared the gulls that we have just here to one, say, closer to the coast. Yeah, it would be really, really interesting to see, to sort of compare different colonies.
Yeah, exactly. I mean, just in the Launceston area alone, I think there's our population, there's certainly another one close-ish by. Those ones tend to roost in one very specific paddock. Not really sure why, but that was definitely one of the points that we considered when starting this project was, can we sample between populations? What sort of would be the go there? That would have been fantastic. Unfortunately, this was an honours project, so it was relatively short.
Yeah.
But in saying that, we've got a fantastic data set. We've got a really great baseline, and so it would be very easy to build on what we've done following the same method.
That's great. All right, so we're at 5 after at the moment, so we should probably move on to the next paper unless Eric's got I hope it's a quick question, Eric. Though I never know. There you go.
Thanks. Just a quick aside, back in the 80s when I was doing some work on kelp and Pacific gulls down here in the southeast, we were finding same sort of results as what Lillian's work has done. Huge amounts of obviously tip rubbish dump source material, and these birds were tracking 30-40 kilometers in a straight line because we knew where the colonies were and we knew where the nearest tip site was, and these birds were quite happily tracking 30-40 kilometers and then regurgitating at the nest. So I'm not sure that you're going to get a huge difference between near versus farther colonies from some of these sites. Just observation.
No, good to know. Interesting stuff. Thanks, Eric.
Thanks,
All
Eric.
right. And I think with that, we'll move on to the next paper. Lillian, Megan, thanks for that very, very cool study. Nice little paper, and it was really fun to read. So, David, I think we're on to ancient penguins, which totally titillates me.
Yes.
We've got Daniel is here somewhere, I thought. Oh, here he is. Yep, there he is, and he's joined by a mega penguin. Alan Tennyson is on as well. Oh, there you go. It's that side of you. How you doing, Daniel?
Is Alan the mega
Yeah, I'm good.
Nice to see you both.
Yeah, thanks for the invite.
Hey, no, thanks for coming along. I'm looking forward to listening to this paper as well. Penguins are near and dear to my heart, and I feel like this paper kind of attacked all my preconceptions. So, all right, David, please take it away.
Yeah, thanks for joining, Daniel, and bringing this really nice paper on ancient crested penguins. I love paleontology. I find absolutely fascinating that so many creatures lived in the past and that we can learn bits by bits about their lives. It really humbles me to think about them. And paleontology sounds like poetry to my ears. especially when authors write about deep time. I love the expression. But avian paleontology is tricky because bird bones are filled with air and do not fossilize well. Penguins are an exception. I talked about it with Daniel Křepka, the second lead author of the paper, and he said, I quote, as a penguin, all you need to do is to sink and get buried. In comparison, if you're a forest bird, it's very hard for you to end up where you will be preserved. So there are plenty of penguin fossils, and those help identify that where this group comes from. The likely cradle of all penguins is New Zealand, probably by lack of land predators. Still today, as you know, it is the hottest hotspot in terms of seabird species diversity. A quarter of all seabird species breed there. The fossil described by the two Daniels and their colleagues comes indeed from New Zealand, and it has been dated fairly precisely to about 3 million years ago, which is very recent for penguins, since they look back at 60 million years of history for this group. Boy, 60 million years of evolution and still flightless. The research team performed detailed morphological studies on these very well preserved fossils and concluded that they are related to today's Eudyptus penguins. So that's rockhoppers, macaronis, and so on. Hence, their findings add to the evidence that Zealandia, that's another word I love, Zealandia, was an incubator of penguin diversity in which the first penguins and likely the first crested penguins evolved and later dispersed throughout the southern hemisphere. Yet the authors found a major difference between the fossil species they call Eudyptus atatu and today's Eudyptus. It's the lower jaw, which is more slender. That sounds like a detail, but it means that deeper bills only evolved fairly recently in Eudyptus. This is where it becomes really exciting, I think, because the appearance of this morphological trait corresponded with a massive change in the hydrography of the Southern Ocean, a change towards windier conditions, which triggered upwelling and boosted primary productivity to the benefit of krill. And to efficiently feed on krill, penguins needed deeper bills. Interestingly, it's about at the same time that baleen whales also developed deeper jaws in the Southern Ocean. So thanks a lot, Daniel, and the team for this very nice paper I enjoyed reading. And I noticed in other illustrations of fossil penguins that these giant penguins of the past, a lot of them had these long, slender, stiletto-like types of bills. Does this follow the same rationale as the one developed in your paper that back in those days they were feeding on something different?
So thanks for that excellent summary. The spear bill, it looks like that this is a trait of these very ancient penguins, the ones that are, closely related to our living ones, but themselves actually have no living descendants. And and if you haven't seen it, it's this, occasionally these things are preserved, but we'll have a penguin that is slightly bigger than emperor size, and it will have just a long spear-like bill. And it's a trait that we have no evidence for after, 25 million years ago, right? So before that time, spear bill we assume is the default. And then we go through this period of time where we don't find skulls or very well preserved skulls, certainly the face of penguins. And then we reach our more modern day ones and they have what we would expect in terms of the bill morphology. So it means that we've got no modern analog from penguins to really figure out what the feeding mechanism or the foraging mode would have been for these spear-like ones. But yep, sure enough, this penguin that we've described here, that Alan and I have been working on with others for a little while now, it looks very much like what we would expect from a modern penguin, just not a modern crested penguin.
Yeah, but so the krill argument I checked, and krill has been around for a very long time. So it was already present as a prey item
Sure.
for a long time before the fossil penguin found in your study.
Oh, completely. And so this is us thinking about potential reasons. So this is one hypothesis for the origin of the deeper bills and eudiptes, the crested penguins, because at a similar time we start to see perhaps deeper bills in the brush-tailed penguins as well. But I mean, it's an idea. If we take a look at the diets of modern penguins today, we know it's not quite that clear cut. We know that there's a diversity of diet that the crested penguins will eat. And sometimes there is a lot of fish in the diet, but oftentimes, you know, these are the ones that are specializing on krill. Certainly some populations are. So it's an idea. It's certainly one that would be interesting to follow up and test with you know, a bit more evidence. All we can really say is that this change has occurred, and it's probably driven by diet because you know, cranial morphology is so sensitive to diet, but we don't have a firm connection for that.
Mm. And can you tell us a little more about where the fossil was actually found and why you named it this way?
I can answer the second part, but Alan is actually the expert on the location. So I'll turn it over to Alan.
Or do you want to answer the second part?
Sure, I'll answer the second part. All right, so the name actually went through a little bit of an evolution, but we really wanted to capture this idea of this being some of our earliest evidence for this particular group. So this is a crested penguin. This is now, for New Zealand, our earliest evidence of crested penguins in New Zealand, a group that is very important to us. And so this name, Atatu, is it's Te Reo Māori, so it is comes to us from Te Atatu, which is the dawn, and hence our crested penguin is the dawn crested penguin, but respecting the local language.
Okay, yeah, very interesting. And so the all today's penguin you define as crown penguins. Do you know why they were named? Well, why the group was named in this way? So that's the way to distinct extinct penguins to today's penguins. So today's penguins you name crown penguins.
Right. So the term crown just comes from when we think about any particular group. We look at all of the living members of that group, think about the most recent common ancestor of those living members, and then all of its descendants. And so when we define our group as penguins, so Spheniciformes, we think about all the living ones are all around the world, and then their most recent common ancestor, and so everything you know, alive from that point, including the ones that have recently become extinct. And so this distinguishes us from all penguins, the ones who, if we go back further into time, they are the so-called stem penguins, the ones who they look very similar to, they're most closely related to our living penguins, but they themselves actually don't have living descendants. And we can tell this because they've got particular morphological traits that haven't survived through into modern day. And so this puts them outside of our so-called crown group. If Dan Sepka was here, he would probably see this on YouTube and send me an angry email for butchering the definition of crown. But that gives us some idea that when we talk about crown, we're just thinking about the modern group to the exclusion of the things that have come before.
Okay, thanks.
All right.
And part two, do you want me to answer part one of that question?
Yes, please.
Okay, well, thanks, Daniel. I thought that was actually very clear. And I should also add that, of course, the Megadiptes, the yellow-eyed penguin, does have this narrow bill as well, and it is the sister taxon to the crested penguins. So it's kind of an interesting point. In terms of the site where these particular fossils are from, it's actually a pretty amazing site. I mean, for a start, it's spectacular. It's a beach with very large cliffs behind it, which are eroding out at a very fast rate, so it's potentially quite dangerous. You know, there are big cliff falls quite frequently, and the fossils are coming out of concretions, which, for those of you who don't know, are basically spherical rocks that seem to form relatively fast around sort of mainly organic matter and things sitting on the seafloor. So the seafloor has to be relatively undisturbed, so it has to be fairly deep, so there's not too much swell and wave action. And as the bones sort of leach out their some of their chemicals, I guess, they create this rock around them, which then protects them into the future. So it's quite a remarkable process, but it's actually quite a common process for marine fossils around the world. So that's how they're forming. But yeah, a little more on the site is that it's probably a relatively shallow sea where the penguins died. It has probably the most exciting thing is actually the penguins are just one part of this fauna. There's a whole range of other animals there, including lots of other seabirds. So we have already described a shearwater and an albatross from there, the very same place. But there's several more to go. There's beautiful seal fossils, some of the best in the world. And there's quite a bit of cetacean material there. And then there's lots of fish, lots of mollusks and things as well. So it's quite a remarkable site, which has not had a lot of research done on it. So yeah, Daniel and I and others are sort of starting to really get into it now, and it's really pretty cool actually, because you know it's a unique site globally, and the material is preserved. Some of it is just fantastic. I mean, perfect skulls and things are coming out, and normally yeah, the delicate bones don't preserve. As you said, the penguin bones are relatively common in fossil deposit because they are solid, but you know, the skulls and the sternums and things aren't particularly solid, and it's preserving every element of these birds. So it's just a remarkable place.
Wow, yeah, exciting. Can you take me there?
Sure.
Yeah, and another question. I noticed that, well, I read that in the Pliocene was not only evolved deeper jaws, they also became larger than any other vertebrates known to this day. And I was wondering why we had giant penguins in the past and not in recent times, like as in whales.
I think that is a fantastic question that I can't answer, but it might be because we have giant whales. So that's one of the leading ideas, that the rise, either direct predation or competitive exclusion, and that it happens over that period. But the challenge becomes one of statistics. So we see, we walk back in time and we find fossils, and they're giving us some information about some of the animals that were living in some locations at some time. But to really show a decrease in diversity or abundance here and a rise there, we would need, I think, some fairly strong, direct evidence. So I don't know that we'll ever have that given the patchiness of the fossil record, but that is certainly an observation that has been made, that when one disappears, an entire foraging guild, the giant penguins, disappears as we have the rise of the large cetaceans.
Wow, yeah. Yeah, Dave Ainley and the gang would love that interpretation and that hypothesis, I'm sure, of the competitive exclusion.
Uh-huh.
And maybe a last question from my side. In the science paper, you quote showing that the Southern Ocean cooled a lot during the last 3 million years. That paper is based on a sediment core from the Benguela in South Africa, and I was wondering whether there's more general evidence of the cooling of the entire Southern Ocean at around that time?
I strongly suspect there is. And so again, as the way that we've done this study is it's been very focused on our particular animal, and then we've reached out beyond to look at evidence for the environment. And I will confess that I'm not a full expert on the Pliocene environment just yet, but as Alan alluded to, there's plenty of work to still be done in this space, and so it's, yeah, I hope to improve my knowledge in this area moving forward.
Okay, because I remember reading that the Southern Ocean sort of started to have the circulation and the temperature it has now about 60 million years ago, so much earlier than that. So I was kind of curious about what happened at the scale of the last 3 million years.
Sure. I mean, so certainly there was a major event around 28 million years, which is the opening of the Drake Passage, right? So
28 million
yeah,
years.
right. And so the so-called transition from the greenhouse Earth to the icehouse Earth, the world gets colder as the circumantarctic current starts to move around and ocean currents change. So yeah, absolutely, this is happening. And in this time, Zealandia is mostly submerged, and we are finding giants in New Zealand and around the world, but we're also finding little ones as well. So at this point in penguin history, we've got our full size range represented and then some. And then what will happen is we will move forward in time, and around 10 million years after this, we'll lose any evidence for the giant penguins. But they just simply haven't been found yet, if they do exist. And then moving forward in terms of Zealandia in particular, it's at about this point that it's going to rise like Atlantis out of the ocean and become more and more terrestrial. And the world will continue to get, there will be some environmental changes taking place, but exactly what happens at the Pliocene mark to really change things and drive krill, I actually don't know. This is a point that, again, Dan was really driving for, and so we'll have to direct that one to him. So I don't know, sorry.
No, but fascinating stuff. Grant, do you have any comments?
Oh, Alan, you look like you were going to say something.
Well, I was just going to add in one extra piece of information just to explain the potential competition with marine mammals, basically competition or predation of marine mammals, and the reason the giant penguins aren't here today. Because it's hard to actually conceive, but if you go back to more than 60 million years ago when there were these giant penguins, it wasn't for like another 30 million years that the cetaceans and the seals were kind of on the scene. I mean, they didn't exist, you know. The whales were still hippos and the seals were dogs, whatever, you know. So, I mean, there was a very long period where that competition and predation didn't exist. So it's, I think there's fairly strong evidence that there is some relationship there between the rise of marine mammals and the decline of the very big penguins. So.
Yeah, well, that's totally wild. So then, following up on that, then, so when did penguins? I'm not going to say lose the ability. I'm going to say when did penguins gain the ability to fly underwater?
Very early, and so this was a passionate motivation for a lot of early evolutionary research. I want to say in the 30s and 40s by G.G. Simpson, and he was really the guy who started piecing all this together. But in essence, penguins lost the ability to fly really early on, and actually Alan has found some of the earliest evidence for this, because as soon as really they are penguins, by our definition of what a penguin is, this is not a flying animal. And so we can, we have birds that were not able to fly at the 60 million year mark, potentially up to 62 million years. And so that's basically immediately after the death of the non-avian dinosaurs. So how much earlier in history than that? Well, we just haven't found those fossils. But current thinking is it happened pretty quick. So because it's incredibly inefficient to be a bird that is giving up flight, right? And so if you're a relatively heavy bird and your mode of foraging is both marine and terrestrial, it becomes relatively inefficient. So there's a very strong selection pressure to become an efficient marine diver. And when we walk through the early penguin history, we see over a pretty short period of time, evolutionarily, what have we got? Certainly by 55 million years, so over this 10 million year period, they're starting to take on the modern aspects of penguins, but they've been sort of divers for 10 million years at this point. So it's geologically rapid. Just like I get to use the phrase deep time, I get to use the term rapid and mean it across 5 or 10 million years. But again, Alan, you have more hands-on experience with these earlier penguins than I do.
Well, I mean, you have said it. Basically, even the very earliest fossil penguins are much more closely related to modern penguins than anything else morphologically. I mean, they're very penguin-like, really. Although they do have certain features like longer, thinner wing bones and things like that. So there is clear evidence of a shift from a flying bird, but going further back in time, there's just no fossils. And I think it's been found across a lot of modern bird groups that at that boundary where the non-avian dinosaurs disappeared, there was just an explosive radiation of modern birds. Most of the modern bird groups went through their main, well, a lot of them, let's say, went through their main diversity very soon after that event. Presumably because there were so many vacant niches available, and so they just filled them in, 2 or 3 million years. The closest relative of penguins are still probably considered to be the Procellauriforms, the petrels and albatrosses, but they don't really look an awful lot like them. So you can see that things happen pretty fast because we haven't got those fossils to fill in the gaps yet.
That's super, super cool. All right. We have a question from Andre down in the chat box who's asked to you, Daniel, if you can make any predictions in the future on bill evolution based on what we know.
No, I couldn't. So when we're looking at a trait, we know that it's a combination of 3 things. We know that there's a historical component, so the trait inherited from the ancestor, that there's a structural component, right? Just what it requires to, mechanically construct that trait. And then there's an adaptation component, right? So how those 2 factors then are applied into the environment and then that modification. And so because you've got 3 variables, when we apply any new selection pressure on a trait, it becomes very hard to predict how that trait would respond. So I don't, have a clear.
But from the side of the resource, of course, with global warming plus overfishing, everything goes towards smaller prey items.
Sure. And so what we would end up doing is selecting, it becomes a classic Galapagos finch scenario, right? Where if you've only got small seeds, then you end up with the small bills. And that may be the scenario. It's just, I think the important term here is opportunistic. So while we might have in our mind some picture of an animal that is starting to hunt out smaller and smaller prey, what we don't know is if these animals have some nascent capacity to explore a habitat that we haven't seen them in yet. Maybe they can dive deeper and they just don't. And so they're able to access a resource that we just don't see them accessing right now. So I don't have an answer because of the adaptability of life, right? I don't know that we would necessarily have predicted the trajectory of penguins based on any one of the fossils that we found. These things become big, but would we have predicted spear-like bills based on what we see now? Well, we wouldn't. Would we have expected them to have also adopted the little body sizes, given that maybe deep diving is where you can get to the most accessible prey? Who knows? So I have no capacity to predict, but I certainly love describing what we find.
And so to be absolutely sure, so you need a deeper bill when you have some sort of filtering mechanism, right?
Right. So in terms of so what we do see is if we completely binarize it, so if we say who are our krill specialists and who are absolutely not our krill specialists, then we can get some picture that the things that eat a lot of krill are our crested penguins and our brush-tailed penguins. But it's just not that simple. But let's assume it is. So what is the mechanism? What is the link between bill depth? And perhaps it is filtering, perhaps it is the volume of the mouth itself that becomes afforded by a deeper bill, right? So, and perhaps it's some capacity to hold or to crunch or to, I don't have a causative relationship between bill depth and the prey item, except somehow having a bigger mouth is linked through to krill.
Yeah,
in
because
some really cool kind of way.
Because in Alcid, especially in Little Oaks, they have fairly deep bills, but they actually store the plankton in a gula pouch underneath the bill. And also we showed that they don't seem to be filter feeding. So I'm still really wondering about why Little Oaks have deep bills. Since they particle feed, they could have small pointed beaks and still be doing the suction feeding they do with the gula pouch.
Well, reviewer 2 pointed out to me that it doesn't really, the idea of having a bigger gula volume, a bigger mouth isn't actually all that relevant for Eudiptes because they're selecting their prey anyway. So even if they're hunting out krill, they're still going to just take one at a time. So there is, yeah, I don't know, but if we just step back and look at the numbers, we certainly see some phylogenetic signals. So we certainly see that modern crested penguins have this deep bill, and we also see it showing up in brushtails, and maybe there is some interesting link here through to krill, but it would be really interesting to figure out the biomechanics of that.
Very cool. I'll ask Steph really quick if she's got any questions for you, and then I'll let Eric ask his question.
I don't. It's so fascinating. Like I just don't even, it's like how big is space? It's one of those questions, like how do you even study paleoecology and this deep history, deep time? I'm in awe and want to hear more about it. So do it again.
There are approaches that we haven't taken, and so there is an entire field of using isotopes to do this kind of work, right? And then we can start to get perhaps some trophic level information. And so yeah, we haven't taken this. There are of course caveats around this, but yeah.
Super cool. All right, Eric, I'll let you ask your question, and then I think we'll go from there.
Thank you. At the risk of being abused by the convener, I'm just curious if there's any fossil evidence to support your speculation about a change in diet. I mean, is there things like otoliths or squid beaks, in preserved, that you could actually look at a shift in species composition for these birds?
No. So really, we've seen a morphological trait, and we've thought perhaps this is linked to diet, and so we've presented this as an idea. But no, we don't have any data right now that we could really follow up and say, okay, if this is something that we're desperately interested in testing, then we could study this data set. So not that I'm aware of. And Yeah, and
Yeah.
I'm getting a shaking of the head from Alan. So
Yeah,
no,
no.
it's just an idea, and it might just be as easily brushed aside as, nope, that was a stupid idea. It's clearly this, and in which case I will think, great, now you have explained to me why this thing has a slender bill, and that's kind of where we're just.
Yeah. Okay. Yeah. It's just one of these things that, if there was the opportunity to sort of come up with some supporting or corroborating evidence to support your suggestion of a change in diet associated with whatever happened, 3-point-something million years ago. So it's just one of these things. If the sediments are good enough, you might actually get a story out of them as well.
Yeah.
Yeah, I was thinking practically, Eric. If we got if we actually did manage to find one of these Pliocene fossils that had stomach contents preserved, I mean, guess what? It'd probably be bones, wouldn't it? And the krill would have disappeared anyway. So
Yeah, but what about
it'd
things
probably
like
be totally
squid beaks?
biased. So
Yeah, I know, but I mean, squid beaks possibly. We did some work with relic to daily penguin colonies, and we had squid beaks, 9,000 years old in some of our colonies. So I'm just wondering if some of this stuff does preserve at all.
There are crabs from this site, right?
Yep. Yeah.
And so they of course have calcite in their, out crabness. What is it?
Carapaces.
There you go. Yeah. Edit that out on YouTube, thanks. Right. So we know that there is some evidence for inverts from the site. There's certainly fish material from this site. In terms of actually getting forensic evidence, it becomes a statistics argument again, which is where we vertebrate paleontologists really do fall over a little bit, because even if we found a squid beak, we wouldn't have. We would have found a squid beak. Yeah, we wouldn't have necessarily found a story or the answer.
Very good. Very, very, very cool discussion. Thanks for that. And I think now it's 20 to the hour, so I think we'll probably call it quits and let everyone get about their days. Daniel, Alan, thanks very much for joining us. Thanks for that really, really fascinating paper. Like I said, that kind of struck me in the heart a little bit. I was a bit sad that my Antarctic penguins are no longer the source population. Oh well, it's the nature of science, right? Steph, thank you very much for joining us today. That was great. It was nice to have you along.
My pleasure.
And
science is a fickle beast,
Is
Grant. It's just hard to know what's going to happen.
Never does what I want it to do. All right, everybody, take care. Stay safe. Nice to see you all. I think I'll turn off recording now.